Hi, folks. I apologize for not being here. This is kind of a spur of the moment thing I had to deal with. Um, with that being said, this week I've left your chapter 4 redos with Miss Thompson. You need to make arrangements with her to when you're going to write it. So please go see her as well. Okay, 2.3. We're going to do a little bit of grade 11, and then we're going to do a lot of grade 12. I prefer grade 11, just for the record. All right, so part A here is determining the roots. So really, that just means we are solving for x. That's all we're doing. If we are doing it on a graph, the roots are going to mean the x-intercept. So we're going to do it grade 11 style, where we're doing it algebraically. So that's what we learned in grade 11. I didn't leave you a ton of room here, and that was a mistake on my part. So please bear with me. A little bit more room than the other page that I gave you 0 room on. All right, first thing we have to do is we have to identify any restrictions on the variable. You guys can't see the whole sentence, but you know what it says. All right, you guys, I'm going to say that we didn't do a great job of hammering this home in grade 11, but what do we know we can't take the square root of? We can't take the square root of negative numbers. So what we need to say is the thing under the root sign has to be greater than or equal to 0, because the thing under the root sign can't be negative. So I'm just looking at the thing under the root sign. And so all I'm going to do is subtract 5 from both sides. So my restriction would be x has to be greater than or equal to negative 5. That's my restriction. So when we're doing restrictions, we're just saying, hey, my graph has to be greater than negative 5. And that makes sense because our starting point is at 0, 0. This has a transformation of 5 units to the left. No reflections or anything. So that means we are traveling from negative 5 that away, right? So that makes sense. That follows the restriction. It's just we don't see that. We don't see the graphic part when we're doing algebraically. So we need to make sure we solve for the restriction algebraically. We don't need that when we're graphing because we know that's our starting point. We have a closed end at that point. So that's the connection between the picture and the math. This was grade 11. We didn't do a great job of doing this, but you're going to be way better. You're going to be way better at doing restrictions now that you can kind of see how it applies to the graph. Okay, old school. We're going to old school, grade 11. Step 1 when solving a radical equation is to isolate the radical. So we're going to move that negative 3 to the other side. So I'm going to have root x plus 5 equals a positive 3. I just added 3 to both sides. That was step 1, isolating the radical. If you have 2 radicals, you would put a radical on either side of the equal sign. Step 2 is square both sides. So we're going to have x plus 5 equals 9. One-step algebra, ladies and gentlemen. X is equal to 4. And that's really exciting. But if you remember, in any radical equation, we have to do the check. We have to do the check. So that's substituting the 4 back into the original equation. So we would have 4 plus 5 minus 3 equals 0. So the root of 9 minus 3 equals 0. And we know that that is a true statement, so that answer is good. Now remember, when we're doing our check, we're using our positive principal roots. So you guys are like, well, it could be a negative 3 and then this would be 6. Not what we're doing here. We are using positive principal roots in our check. So square root of 9, we're going with the positive principal root of 3. So we know 3 minus 3 equals 0. Okay, so go through it again. Step 1, isolate radical. Isolate radical. Had to sound it out to spell it. Square both sides. Then we solved. And then we checked. Another place you have to check is you have to check for, does it work? And you have to make sure that it satisfies the restriction. Check equation and restriction. All right, so it's 4. 4 is definitely greater than -5, so we're all good. So what we know is the solution to this equation, the root of this equation is x equals 4. That's the answer, but I needed all the other stuff to go along with it. Let me slide this over just in case you were still writing. Okay, sorry, I'm trying to pause just so that you get a moment to figure out your life, get everything written down. Maybe a moment's not going to be enough to get this all figured out. Okay, so 2 ways we can do this. There is 2 ways that we can do it. We can graph it just the way it is here using transformations. So option A is graph using transformations. We're determining the x-intercepts of our graph. So we're solving for the roots. We are solving for the zeros, right? So using transformations. So that's straight up, we're going to use y equals root x plus 5 minus 3. We can do the transformations on that. Option B, we can split it into 2 equations. You ready for this? So what we would do is we'd bring the 3 to the other side. So we would have 3 equals, again, we're isolating the radical. And we would graph y equals 3, and we would graph y equals root x plus 5, and find point of intersection. That was a lot of writing, and no math was done. That's sad. So those are your 2 options. I'm going to tell you honestly, option A is probably where you're going to go to because you're going to be using transformations so much. I can show you using Desmos how to do it, but I think that this video shuts down as soon as I close the screen. So with that being said, I don't think I can show you on Desmos, but I can show you on my graphing calculator. Maybe I'll do that. Okay, so let's go with option A for right now. We're going to say that we're picking option A. And so I'll show you how to do that. We're talking about the transformations here. So if we're looking at this, we have 2 shifts. We have no stretches. We are 5 left and 3 down. All right. So we're going to go back to our original table of y equals root x. And remember, those were very purposeful ones, 0, 1, 4, and 9. So this would be 0, 1, 2, and 3. Remember, we are super purposeful with that. So now we're just going to apply our transformations to it. So all of our x's we're subtracting 5 from. So my new starting point is at -5. And then we've got -4, -1, and +4. And then for our y's, we're going to move 3 units down. So we're subtracting 3. So -3, -2, -1, and 0. Do you see the answer? It's right there. But it says we have to do it graphically. So we're solving. So if we use transformations, we're looking for, I guess I should say, look for x intercepts. Okay, so we're looking for the x-intercepts if we're doing it with transformations. If we're splitting it into two equations, we're finding the points of intersection where those two graphs cross each other. All right, so we're just going to go ahead and graph now. Slide this over so we can kind of see our blue table. And the increments. I'm going to go -1, -2, -3, -4, -5. Ooh, 4, 5, sorry, that 4 should be on that one. All right, then I'm going to do ones again. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. I always kind of mumble to myself when I do that. I have to label every increment. It helps me graph better and not miss points. You, ladies and gentlemen, may be a much better grapher than me, and you may only need to label 5, -5, -5, and +5. So it's really what works for you, but this helps my brain, especially after I've done math all day, so I don't miss a point. Okay. Let's go -5 and -3. Remember, that's our starting point. Sorry, I'm drawing arrows and you can't see it. That's our starting point. So that's going to be our closed circle. So -5 and -3. So right here. And then we are going to have -4 and -1. -1's right there. And then -1. Oh, sorry, that was supposed to be -2. Jeez Louise, who let me graph things? Let me get rid of that dot real quick. It's like it never happened. See? This is what happens when I'm not using erasable pens. -4, -2. Then we have -1 and -1. And then we have 4 and 0, which is way over there. So I bubble through my first two, and I continue through my points. So that's kind of a stretched out graph. That's really stretched out. But what you need to do now is you need to state the solution. The solution is the x-intercept. Right? So that 4 is the solution. So we would say that x is equal to 4. That is my x-intercept. That's the solution to the equation. So if I ask you to find the solution through graphing, I'm looking for the zeros of the function if you're going to graph it as a single equation using transformations. So part C, describe the connection between roots of the equation and the x-intercepts. They are the same thing. And the other word that we use for them, we have roots, we have x-intercepts, and sometimes the other word is zeros. So we've got 3 names for them. You guys know this, kind of redundant, but it's always good to try to go back and remember. All right. Okay, so this question, done, pretty easy. But as most things in our math class, they start off pretty easy and then they get a little bit more complicated. Now, if I were to ask you to graph something solved by graphing, there is no law saying that on a scrap piece of paper, you can't solve it algebraically just to double check that your answers are correct. Like, there's no rules about that. So let's go ahead and do this. All right, so step 1, we're going to do it algebraically first. We're going to do that scrap piece of paper. Isolate the radical. Good news, radical's already isolated. So we're moving on to step 2, which is to square both sides. So I'm going to have my x plus 5 squared equals x plus 3 squared. And if you guys remember, this means we have to expand. So this is just going to be x plus 5, but this side's going to be x plus 3 times x plus 3. If you don't do that, you're missing out on the middle term of the trinomial, and that would be incorrect. So we're going to have x plus 5 equals x squared plus 6x plus 9. Again, if I'm solving for the zeros. I need to bring everything to one side and factor because I have an x squared. So I'm going to bring this stuff to the right-hand side. So I'm going to have 0 equals x squared plus 5x plus 4. And if I factor that, I'm going to have x plus 4, x plus 1, and then it would be x equals negative 4, and x equals negative 1. So 2 solutions. Life's great, sort of, kind of. But now we got to check, right? So this is grade 11. This is what we learned in grade 11. If you're not sure about the math I just didn't show all my steps just because we don't have a ton of room. But I'm going to check both my answers. So I'm going to check, and I always check into the original equation. So I'm going to check negative 4 first. So I'm going to have negative 4 plus 5 equals negative 4 plus 3. So root of 1 equals negative 1. So remember, we're looking for the positive principal root here. So 1 does not equal negative 1. So we're going to go ahead and reject that answer. You must show that you've rejected it. You can't just assume that this and this. You have to show that this isn't a valid answer over there. I've said that a lot in grade 11. We haven't done as much solving in grade 12, so I feel like I've done you a disservice and I haven't said it enough to you. All right, so we have the square root of 4 equals 2. 2 equals 2. That's true. So that one's a good answer. Okay. Life's pretty good. Welcome to grade 11. Remember when that was hard? And now you guys, it's easy peasy. Hopefully. All right, so now we run into a problem. Now we run into a problem because if I bring things to the other side, I don't know what that x does transformationally speaking. Oh, sorry, that should be equal to 0. I don't know what that x does transformationally speaking. So I can't do this one with transformations. It's a no-go. I cannot do it. It's bad, oh bad. I can't apply transformations with that random x that's not under a root sign. So I've got to do the points of intersection at this point. So sometimes it will work, sometimes it won't. This I must use two-equation method. Not a big deal. We did that. Did we do it today? Sorry, today is not today for you. We did it on Friday. So not a big deal. We can do this. So we're going to be graphing y equals x plus 3 and y equals root x plus 5. Super easy to do this one. Kind of easy to do that one. So don't fret. We're good at what we're doing. So I think I'm going to graph my radical first, just so I can get my table of values out of the way. So y equals root x. I'm going back to that original table of values, 0, 0, 1, 1, 4, 2, 9, 3. And then I'm going to do my transformed graph, x plus 5. So what does that mean? It means we're shifting our x's 5 units left. So we're going to be subtracting 5 just from the x's. That's all we're doing. So negative 5, negative 4, negative 1, and positive 4. And my y values stay the same. So 0, 1, 2, and 3. All right. I'm going to graph those again. I'm going to put my increments on. You know what? Sometimes it's better to see a table of values for both. But this is x plus 3. I know I can go either way, like forwards or backwards with the slope. So 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. I have faith that I can graph that linear equation one kind of in my head, so I know that this scale should work. Now that I've said that, let's hope it does, because then it will just be silly if it doesn't. Okay, so let's graph this one in blue. We'll graph that one in the light blue. We'll graph our radical graph. So we have -5 and 0, -4 and +1, -1 and +2, and then 4 and 3. So bubble through the first two, and that is my y equals, sorry, you guys can't see that, y equals root x plus 5 graph, because I'm going to have two graphs on this. So now I'm going to go ahead and I'm going to graph my linear function. So I had a green pen. Oh, there we go. So I'm going to graph my linear function in, I think I'll do it in pink, just so you guys can see it, see the difference. I have a better pink than that. All right, so +3, and my slope is 1/1. So up 1, 1 to the right, up 1, 1 to the right. That's not enough data points, and you see that they don't connect, so I'm going to go backwards. I'm going to go down 1, 1 to the left. Ooh, perfect. Down 1, 1 to the left. Down 1, 1 to the left. Okay, and if I've done that right, it should be a straight line. And this one is my y equals x plus 3 graph. Sorry, you guys can't see that. All right, so we're looking for the point of intersection. The point where the two graphs cross is right there. It's not necessarily good enough to circle it. We need to make a statement. We need to say that x is equal to, so I'm only looking for the x coordinate where they cross. X is equal to -1. And that would be my answer to this question. And if we slide back up real quick, what was my answer? X is equal to -1. So algebraically it works, graphically it works. Like I said, if I ask you to do this graphically, I expect you to be able to do it graphically, but there's no rules against you getting a piece of scrap paper and doing it algebraically just to double check. Some of you may not have the confidence in your solving radical equations, and that's okay. So maybe the scrap piece of paper isn't a method that you're going to use. Anytime I give you these graphs, you'll probably see a point of intersection that is fairly nice. All right, so the solution to this, if we were to solve this graphically, the solution is x equals 1. All right, there we go. Pause the video anytime that you need to get caught up, if you need to move around. The note package is actually on my desk, filled in. It's also online, so if there's something that you've missed and we're just going too fast and you don't want to interrupt the class, please note that these notes are already posted on the Google Classroom. So they're there if you need them. All right, moving right along. Oh dear. Oh dear. Okay, here's the deal with this one. If you were to solve it graphically, you're going to need technology to do this because it becomes very ugly very quick. But again, you need the strategy. So I'm going to do it in my graphing calculator just so I don't have to stop the video, but then we'll solve it algebraically. You need to use the strategy of the two equations. So you've got y equals root 3x squared minus 5, and your second equation would be y equals x plus 4. Now, if these were not rearranged, again, step 1, isolate the radical. I don't believe there's any assignments like this. If you find that you're struggling with it or it's not working out right, throw the two equations in Desmos and see what they look like. see if I gave you a crappy equation. I don't think I did in your assignments, but I've been known to think one thing and do something else. So I'm going to put these in my graphing calculator. Let me clear my old ones out. So we are going to take the square root of 3x squared minus 5. I'm going to go down to my next one, and then it is x plus 4. All right. Huh, that's interesting. I got to change my window because we can't see anything. So I'm going to go zoom, option 0. That looks even worse. That looks even worse. All right, so I'm going to change my window. Y minimum, I think I'm going to back that off to 5. 10 is good. Ooh, Y minimum, that's crazy. -2, and let's go up to 20. Oh, there we go. Now we're seeing a better graph. So the blue one is the first one. That's the 3x squared minus 5. And the red one is the x plus 4. So on this graph, that's weird. It's sitting above the line a little bit. That's something like that we haven't experienced before. I wouldn't expect you to graph this without technology. So then I can go second function calculate, and I can say, hey, where do they intersect? So option 5. I want to get back. I want it to hop to, where did it go? Hang on, let me get it back. Okay, I'm gonna say, yeah, that's the first curve. Yeah, that's the second curve. Yeah, figured out. So it gives me that point of intersection. So that far one there, let me draw a rough graph of this. So we've got like this, and we've got like that, and then we have the blue line, or the red line going through, that kind of goes like this. And this point of intersection is at 5.807. So x is 5.8, I'm going to say 81 just because I don't have a ton of room. And then I've got 9.81. All right, so if I need to go back to my other one, oh, I got to go second function, option 5. I need to go backwards. There we go, there it is. So what I need to do in a graphing calculator is I need to make sure that that little dot is close to that point of intersection. First curve, second curve, yes. Do I guess? Yes, I want you to guess. So the point of intersection at this point here is -8.1 and 2.19. Okay. The reason why that's helpful is when I go to solve ugly ones algebraically, it's going to be very helpful for me. Okay, so really what I know is algebraically speaking, my answers should be this and should be that. Those are my two answers that I should get algebraically. So now we're going to solve algebraically. So we're going to go old school grade 11. So 3x squared minus 5 equals x plus 4. Step 1, isolate the radical, which it's already done. So we're going to go ahead and square. So that's going to be 3x squared minus 5, because the squared cancels out the root sign. This we have to expand, so we're going to have x plus 4 times x plus 4. I know you guys want to skip that step, and I have no problem with that, but the trouble is your brain going to remember to expand the binomial? If you don't think it will, if you don't trust yourself, write this step out. If you're confident, then don't write the step. I'm okay with either. And I'm not even showing you the full expansion. I'm like, oh, that's 8, and that's 16, done and done. Because I think we learned that in grade 10. All right, so I have x squareds. I'm going to bring everything to the left-hand side, because then this is going to leave that positive. So I'm going to have a 2x squared minus 8x minus 21 equals 0. So again, I went through and I did things really, really fast. FYI, not factorable easily. So we have to use our quadratic formula. So let's see how many of you remember. Quadratic formula, x is equal to negative b plus minus the square root of b squared minus 4ac. Somebody's got a tattoo of that somewhere, I'm sure. So x is equal to, it is negative 8, so that means it's going to be a positive 8 plus negative 8 squared minus 4 times 2 times negative 21 divided by 2 times 2. Oh, guys, plus minus. I forgot my minus sign there. Oh, I was getting all cocky like I knew what I was doing. So if you do this math, it's 64 plus 168. It's going to be a plus because negative, negative, right there, all over 4. If you have a quadratic solver, obviously you can check your answers in that as well. 232 divided by 4. But again, you won't have your quadratic solver on a test or the exam. So you need to know how to do your formula. So if you trust my math, one works out to be 581 and the other one works out to be negative 1.81. And we anticipated those answers from graphing it using our technology. So if I give you a crappy one and I'm not here to ask about it, skip it, wait till I come back, and then we'll go through it there. I just looked out the window and it's snowing. Oh, breaks my heart a little. Okay, one more example and then we're done. This lesson goes way faster when I don't slow down, and I apologize. Again, stop the video, do what you need to do, look at the notes online. Okay, last one. It's a bunch of words. What a way to end a lesson with a bunch of words. Do you notice we do this to you all the time? All right. An engineer designs a roller coaster. Yes, roller coasters are designed by mathy people. We've got to make sure that you have, well, physicsy people, which are mathy people. We've got to make sure you have enough energy and speed, velocity, so that you make it through those loops, those upside downs, and you don't come flying out of your seat. So she models the equation of V equals V initial, so that V0 is what we call V initial if you haven't taken physics before, squared plus 2 times A, and A represents, excuse me, I'm looking for it here, constant acceleration A, so our acceleration, and D is the distance, the dropping distance in feet. So how much velocity are we going to get from that certain drop? And the initial velocity is the push out from, from the starting point. Okay, so we know that things are done in feet per second. So right there, sorry, I underlined it, but you can't see it. So I know my D is in feet and my velocity is feet per second, and my acceleration is in feet per second squared. All right. The design specifies the speed of the car must be 120 feet per second at the bottom of the vertical drop. So is that V initial or is that V final? It's at the bottom of the drop. V initial is when we start before the drop. So we know that V is equal to 120. If the initial velocity of the coaster, so that's V initial, V0, like it's beginning at time 0, right, is 10 feet per second, and the acceleration is only due to gravity, is 32 feet per second squared, so A is 32. Find the vertical drop distance we need to the nearest foot. So we are trying to solve for D. I think ever since I started doing math, I always make sure I have these things figured out, and I label them like this all the time. It's just who I am as a mathematician, and it makes my brain happier. All right. So 120 equals 100 plus 64D. All right, I did some math there. I hope you're proud of me. Okay, all it is a radical equation. I'm asking to solve it algebraically. There's no graph on the page. So again, we're just kind of walking back into grade 11. So step 1, isolate the radical. It's already isolated, so I'm good to go. I'm going to square both sides. So this is going to be 14,400. And this will be 100 plus 64D. I'm going to minus 100 from each side. Oops, sorry, it didn't show that. I've been doing 2-step algebra and 3-step algebra with my grade 9, so I'm getting really good at showing. We're getting really good at showing my my steps, and then when I come to you guys, I just sort of drop it all together. And so if I do that handy calculation, get out of that graph. Nobody wants to look at that anymore. So 223.43, and I'm rounding to the nearest foot. So it's going to be 223 feet. So don't forget your units of measure. All right, ladies and gentlemen, again, I apologize for not being here. It wasn't my intention. Chapter 4 redos are with Thompson. Make a time with her. You can't just show up and expect her to be available. So you need to go see her and say, is this time okay? She's pretty flex. If you need a different time, we can supervise in the office. Thompson can answer questions. The office probably can't. So take that with a grain of salt. I will be back as well. Don't worry, I'm not leaving forever. And we'll see you guys when I get back. Thanks for being flexible.